Okay, here's a few examples of solving exponential equations. You'll know it's exponential if you have an exponent in your, a variable in your exponent. Then you'll know you can't use regular solving methods. We have to use a few little tricks that we've learned. Now, all of the examples I'll do in this lesson will be examples where we can write both sides of the equation as a number raised to the same power. Okay, so go to the next one if it's something that doesn't fit that. But for this lesson, the first thing you want to do when you look in an exponential equation is make sure the exponential part is isolated, which this is. Now this is just 2 to a variable. There's nothing multiplied in front. There's nothing added on the end here. Okay. The next thing you want to do is check to see, because it does simplify your work. Check to see if we can write both sides with the same base, okay? And so notice this is 2 to the 3x minus 1. Can we rewrite 16 as a power of 2? And we can, because 2 to the 4th power is 16. So that's what we want to do. We have 2 to the 3x minus 1, and we're going to rewrite 16 as 2 to the 4th power. Okay, now notice we have 2 to whatever 3x minus 1 is, should be equal to 2 to the 4th power. Since we have the same base, we know that 4 and this 3x minus 1 are going to have to be the same thing. So now that we have them written to the same base, we can just go ahead and write down the equation 3x minus 1 equals 4 and solve that to get our answer. So just as we would with a normal equation, we add 1 to both sides and get 3x equals 5, and then divide both sides by 3. We get x equals 5/3. Okay, so there we have it. Our answer is x equals 5/3. All right, let's try another example. This time we have 3 to the x plus 5 equals 81. So again, the 3 is isolated. This one with the exponent is isolated. So from there, what we want to do is check and see if 81 can be written as a power of 3, just like the 3 is. And if we check, we find out that 3 to the 4th power is 81. So we rewrite 81 as 3 to the 4th power. It's the same thing, it's just written differently, and it conveniently helps us here because we're saying 3 to the x plus 5 equals 3 to the 4th. So we know that since these are both 3's down here, that x plus 5 and 4 must be equal to one another. We have to have the same exponent because we have the same bases. So we're just going to cancel those 3's essentially and have x plus 5 equals 4, and we would solve that equation. And we come up with x equals -1. And again, notice all of these that we're going to do in this in this lesson, you'll be able to rewrite them. So that's what we're practicing in this lesson. All right, now we have 4 to the x power is equal to 1 over 32. Now, I just told you that these would all be able to write as the same power. 32, or 1 over 32, is not a power of 4, okay? But it is a power of 2, okay? 2 to the 5th power is 32. So we're going to what we're going to do is rewrite both of these as powers of 2, because 4 is the same as 2 squared. Oh, sorry, I've got arrows instead of a pen here. 1 second. Okay, so we rewrite 4 as 2 squared to the x power. Now, 1 over 32, this is the same as 1 over 2 to the 5th power. Okay, but remember, if it's in the bottom of the fraction, that means it's got a negative exponent. So we could write it up here as 2 to the -5th power would be 1 over 32. Okay, we've wrote those as powers of 2. I'm going to simplify this left-hand side a little. Notice I have 2 squared to the x power. If you remember your rules of exponents, when we raise to a power, we multiply those powers. So this is 2 to the 2x equals 2 to the negative 5th. Now we have it written, okay? There's no extras hanging out. They're both written as powers of 2, so we can set them equal to one another. And we have 2x equals negative 5. And again, this only works if you can write them as the powers of the same number. So we end up with x is equal to negative 5 halves. All right, a couple more. We're going to get a little more complex as we go along. We're going to do 2 more that are a little more complex than the others we've done so far. 5 to the 2x minus 1 equals 125 to the 4x plus 3. So first of all, what we want to do is write both sides as a power if we can, which we can, because 125 is the same as 5 to the 3rd power. And you may just have to do a little trial and error with your calculator. I know everyone doesn't have, all of the powers memorized, what 5 to the 3rd power is. And if you don't, you always can just try it out with your calculator. If it doesn't work that way, then we can use logs to solve it. It just won't be as neat and tidy. So we have 5 to the 2x minus 1 is equal to 5 to the 3rd to the 4x plus 3. We can go ahead and eliminate those 5 because they were the same base, and I get 2x minus 1 equals 3 times 4x plus 3. And I go ahead and solve that equation. So I'm going to distribute the 3, and I will have 2x minus 1 equals 12x plus 9, and solve my equation. I subtract 2x from both sides, I get 10x plus negative 1 equals 10x plus 9, and then subtract 9 to move it to the other side, and I get negative 10 equals 10x. And last thing I would need to do is divide both sides by 10. And my solution is that x equals negative 10 divided by 10, which is negative 1. Okay, so again, we went through the same process. We wrote them both as a power of 5 because that was possible, and then we set the powers equal to one another and solved the equation. All right, here is our final example. We are going to solve this. This one is, notice it has fractions in it. It has a 9 times the 3 to the 5x. Our first job, anytime we do an exponential problem, is to isolate the exponential part. But notice we have exponents on both sides, an x and the exponent on both sides. So dividing by 9 would just move it to the other side. So what we're going to try to do is write everything as a power of 3. That's what we're going to try out. So let's start at the front there. Can we write 9 as a power of 3? We can. 9 is 3 squared. So we have 3 squared times 3 to the 5x. That part was already written as a power of 3. Equals, now notice 1/3 is 3 to the negative 1 power. Again, that's how we get those fractions down there. So we have 3 to the negative 1 power to the 3x. Okay, now we've written everything as powers of 3, but we need to combine these two. Now, just think for a second about our rules of exponents. And maybe it's easier if you use variables. If we had, for example, x squared times x to the 3rd, do you remember how we combine those? We add the exponents and would get x to the 5th. So when we combine over here, when we combine our 3 to the 2nd power and 3 to the 5x power, we're going to do exactly the same thing. We're going to get 3 to the 2 plus 5x, just using our rules of exponents. And on this other side, We have 3 to the negative 1 to the 3x. When you raise to a power, you multiply the exponent. So we just go 3x times negative 3x times negative 1 is a negative 3x here. Okay, so we wrote everything as a power of 3, and then we simplified those to combine anything that we could. And now notice we have 3 to a power on both sides. So we can go ahead and set those exponents equal to one another and solve them to find x. So I have 2 plus 5x equals negative 3x. And we just go through our steps to solve. And I get 2 equals negative 8x. And then I divide both sides by negative 8. And I get x equals negative 1/4. And there is our answer. So there are some examples of solving exponential equations when it's possible to write them as powers of the same number.